Let's talk about sine waves. Okay, the sine and cosine. That's the number you're going to plug in there for B. Okay. For project purposes, you get to pick your result. I would just put 1 myself to make it easy. Okay. You can pick 2. That would be a little overboard, but it's your choice. Is determined by the note that you've chosen. I showed you a middle C at 261 earlier, right? So that's what you would plug in right there. And Tuesday, and then you should have it. Okay, so that's our music application there. But as far as the parent function goes, they're pretty straightforward. I recommend memorizing them. Okay, if you can just recall these out of your brains. I use these half the time, and I use the unit circle about half the time to get my sine and cosine values. Okay, so let's start with the sine of x. So no longer are we going to be spinning in circles. We're going to be going to the right and to the left with sound waves. Okay. Let's do a grid. Oh, perfect. These are called periodic functions because they repeat. That's what's nice about them. Once you have one little snippet of it, you can just copy and paste them. Bam, bam, bam. They just keep going. Okay. So what I'm showing you is one period. For this, the A value that I showed you earlier is 1. Okay, so we go from 1 to -1. And what if I'm on the unit circle? Go 0 to 2 pi for 1 period. And I like to break it into pi over 2, pi, 3 pi over 2, and then I'll have to extend 2 pi. Okay, that will be one period or one cycle, one repetition of this function. Okay. Okay. We're gonna you can use the unit circle to build these. What is the sign at 0? If you're on the unit circle. Our point is 0, 0, right there. Okay. What is the sign of pi over 2? Yeah. 90 degrees, right? What's the sign value? 1. So our point is pi over 2, 1. Okay. What's the sign at pi? No. It's 0. Yes. Remember, pi is 180 degrees. So that's right here. The y value again is 0. Okay. So my point is 0. All right. 3 pi over 2 is -1. So that's right here. And then 2 pi is 0 again. That's where these two match. All right, and you see the general. There's your graph, the parent function. I use this to remember 0, pi over 2, pi, 3 pi over 2, and 2 pi. Just works for me. If it doesn't work for you, the unit circle is good too. So we have a maximum and a minimum at 3 pi over 2. It's increasing, decreasing, increasing. Okay. If I either direction, all I'm going to get is a repetition. It's just going to go like this. And I could stretch it this way and it'll go like that. It just repeats. Like I said, take and it goes on forever. Okay. But -1 to 1, those are your top and bottom. Okay. And remember, one of the keys to sine is remembering it starts at 0. Okay. When you compare it to cosine, cosine starts at 1. So there's the big difference. Okay. Any questions? Do you think you can answer those? Okay. All right, cosine. It's going to be a very similar pattern. Again, -1 to 1, and then I do by pi over 2 pi. Pi. should be a 3. So same setup. Cosine at 0, which minute on your grid. Graph paper makes these a ton easier. Of course, I'll be looking for that when I get your homework. What's cosine at 0? Yeah, that's it. And then pi over 2. So notice the downward trend. What do you think pi is going to be? -1. Now we're at the bottom, right? So where's it probably going to go next? 0, and then back up to 1. Okay, so this one looks like that. This is smiley face because we like math. But that's all right. If we went from pi to 3 pi, it would be a frowny face. Right. Okay. So your basic cosine function, 1 period. So this would be, come on. Okay. And again, if I kept going, it would just do this again. Again and again and again and again. Okay. So, yeah, you're going to, so on the homework, I'm showing you the parent graphs. You're going to be taking different chunks. It might say graph it from pi to 3 pi. Okay, so if I were to graph this from pi to 3 pi, that's what I want to graph, right? So you always start and end in the same spot every 2 pi radians. Okay, 1, 2 pi radians, 1. Okay, so it's just a repetition. It might say, okay, graph cosine from pi over 2 to 5 pi over 2. Okay. So you just have to figure out what part of the function you're working with and take that chunk out. Okay. From 0 to 4 pi. So 4 pi would be out here. All right. Okay, that's 2 cycles. Okay. So you just got to figure out mentally where that's going to sit. Okay. Let me make sure we got all the words in there. I think that's about it. Rehash some old concepts here. What's the domain of this function? Yeah, it's all the real numbers. So the x values, right? The range? Yeah. You can write it as an interval. We can write it as a set. If you wish. Okay. Close. Either of those works. The period is 2 pi. We've already talked about that. Let me make sure we got all the words here. Domain range. Oh, x-intercepts. Okay, obviously for cosine are pi over 2 and 3 pi over 2. And 5 pi over 2, and 7 pi over 2, and so how could I write that mathematically, so I don't have to say them all and spend the rest of my eternity talking about radians? Okay, so that's how I would write the intercepts. I have pi over 2, and this k has to be an integer. Remember, the integers are all the whole numbers and 0, negatives and positives. So if I had a 1 here, pi over 2 plus pi gives me 3 pi over 2, right? Pi over 2 plus 2 pi, 1, 2 gives me 5 pi over 2. So there's how you could write the x-intercepts. The y-intercepts, of course, for cosine is 1. And we talked about max and min, okay? Already, but we can write it down too. If I extend cosine to negative pi over 2, and I cover this up, what does that look like? The sine curve. Yep. Okay. This is why we only worry about sine curves for sound waves, because they're essentially the same. It's just shifted by negative pi over 2. Okay, so you take the sine curve and just shift it pi over 2 to the left, and you have a cosine curve. Okay, so you really. Okay. Are we good? I think everything is clear as mud, right? Yeah, I think you could probably handle the rest. I haven't mentioned it, but if I said, where is cosine negative 1, what would you say? Yeah, where is cosine negative 1? What is the x value? Pi, right? Cosine is negative 1 at pi. So that's another question you might need to answer. Okay? Well, that's it. I don't want to keep talking if I don't have to, right? Let me write your work down and we'll get you going. Okay. Like I said, I'm trying to minimize this as much as possible for you. So feel free to work on the homework right now if you want, or you can grab a computer and put those frequencies and write your sine functions for your project if you want. Okay. Yeah, 68. I'll be right there, Cade. Let me shut this video down. Yeah, I'll bring it back.